When working with containers, you need a quick and easy way to determine whether your services are behaving properly or not. More importantly, how quickly and easily can you access container logs to help troubleshoot problems? All these form part of what we're going to talk about today, observability. Hello, young public spot, I'm George. On the previous episode, I showed you how I simplified container orchestration to a cloud infrastructure using Kubernetes. In today's episode, I will show you a simple but very powerful tool that could help kickstart the observability of your container-based systems. So, let's start coding. What I will show you today is how to configure Dozzle to set up a basic observability for the containers running in Docker Compose. And I think you will be better off getting the value of what Dozzle is if you have a set of existing containers to play around with. So what I suggest you do is head to the episode on how I use Docker Compose to simplify the orchestration of Docker containers to the cloud, which you can access right here. And when you're ready, head back to this episode to see how you can hook up Dozzle into your existing set of containerized systems. And if you are curious as to what Dozzle is all about, there is a website that contains a large amount of information about this tool, and that's in Dozzle.dev. What I am going to cover on this episode are the steps that we need to configure Dozzle as observability tool to a web-based system that I have orchestrated using Docker Compose. We are also going to cover how to use OpenTofu and Terraform as a way to reflect changes into my Docker Compose infrastructure. And all of this we will cover later on. And so to start, let's get to the Get Started section on this page. And this page provides all the different scenarios or ways you can configure Dozzle. But what I am interested in is how this setup is done using standalone Docker, which is the section right here. I need to know what changes I have to put in place into my Docker Compose file to use Dozzle for my containers. So we need a standard service name, the Docker image, a volume mapping, and port mapping. The image property is self-explanatory, and we know that the port mapping is required to allow access to the Dozzle service from outside the container. I will have a different approach for this property, which I will point out later. And then we have the volume mapping. So why do we need this volume mapping? We are doing it this way to allow Dozzle to pull all the observability artifacts associated to the Docker service running inside the instance. This is the most simple approach because this allows me to track all Docker containers running inside the instance regardless of how they are started. Now let's start doing some actual work. So let me switch to my cursor session. This is the same repository that I created to simplify container orchestration using Docker Compose. So let me open my Docker Compose file on the root of this repository. Now let's implement the setup steps that we just saw earlier. We will start by adding a new service and call it Dozzle. We know that we need an image property. And we need the volume mounting property. We learned from the documentation that I also need to add port mapping. But we also know from the previous episode that I made all the core services not accessible from outside the instance. And the only way to connect to these services are through the Nginx service. So what this means is that I need to reconfigure my Nginx service to allow public access to the Dozzle service. And to do this, let's head to the Nginx directory and open my custom Nginx configuration file. What I need is a new upstream block, and I'm going to call it upstream Dozzle. I am going to configure my Dozzle service as a server target. The Dozzle service runs at port 8080 by default. Hence, I am going to use the same port to target my Dozzle service. So now that I have an upstream, I can then configure a new server listener block. I will configure this to listen on port 88 on the localhost server. And then I am going to set up the root path and route the request to upstream Dozzle. Note that we are letting Nginx open and listen for requests on port 88. So what we need to do now is go to the Docker Compose file and update the service definition for Nginx. Nginx will be listening on port 88 as well, so we need port mapping for this to enable traffic to flow through. We also want Nginx to start only when all the critical services are started, so I need to update the depends on property and add Dozzle. So that's all the Docker Compose related changes that we need. So let's go ahead and push these changes to the main repository. So let me open my terminal session. So all my Docker Compose file changes are now committed to the remote repository. Before we start automating anything else, let's just quickly look at how we can manually update my containers on the upcloud instance. I already have an upcloud instance running with all my web and backend containers running as well. So what I would do to start the manual process is to SSH to the upcloud instance. I know that when the instance is created, the GitHub repository is pulled into the instance, which would explain why, if I ls to this directory, I have this Nginx node redis directory created in here. So what I will do is cd to this directory, and then I have remote changes in GitHub. So what I need to do is pull in all these changes into this session that I have on the instance. So I am going to run git pull. And to rebuild my Docker images and recreate my containers, I'll run Docker Compose with the build flag. So what I just showed you is that I ran two commands to reflect my changes and start the updated versions of containers on my upcloud instance. What do we need to do to make the chain automated and would not require me to connect to the instance and rebuild my containers by hand? So let's exit the current session on the upcloud instance. And on my cursor session, I'm going to open the main.tf inside the infra directory. You may naturally think that maybe I can just add the two commands that I ran manually in the list of inline commands on the remote exec property. The problem with doing this is that this list of commands only get run when the instance is created. So let me show you. So let's go ahead and add those commands anyways. So I need git pull, and then I need to update the docker compose command and add the build flag. Now let's open my terminal and start running my usual tofu commands. Remember, I've made changes to main.tf. So now if I run tofu plan, it says no changes, which means the update will never get triggered. So what we need to do is update the Terraform code. So let's go back to my main.tf. And then at the end of this file, I will define a new resource block for my Terraform data resource. And for simplicity, I will ensure that this resource is recreated. So I will add the triggers replace property and set this to the UUID, which will always generate a unique ID on every plan. And then I will add a remote exec provisioner inside this resource block. So what I'm going to do is copy the existing remote exec block from my instance and plug that into this block. Because this remote exec provisioner is no longer run inside an instance, I need to update the host property of the connection details to point it to the instance resource instead of itself. And then on the inline property, all I need is the last command. So I am going to get rid of the rest of the commands. And then I will update this command to add the two commands that I manually ran earlier, which are already there. So you've got the git pull and the build flag on the Docker compose. And because I'm running this inside this Terraform data resource, I no longer need to run this as part of the creation of the instance. So let me head back to the instance property and get rid of this. And now we have automated the process of rebuilding our Docker image and restarting the containers to use the new version of the Docker images. So let's go ahead and start applying these infrastructure changes. So let's open my cursor terminal. And then I am going to rerun tofu init, tofu plan. And then let's apply this change. So the TOEFL apply completed successfully. Now let's verify if the web application still works. So I'm going to copy this and then switch to my browser and then load the page. The web application works, so let's try to refresh that and see if everything is intact. It is. Now what I'm going to do is I'm going to open a new tab and load that same page. But instead of connecting to port 80, I will connect to port 88. And now I have a working Dozzle dashboard that shows all the containers running on my upcloud instance. I can have a look at the logs of all the containers running inside this instance, which are right here. So I've got Dozzle itself, Nginx, Redis, and the two web applications. I can have a quick view of the CPU and memory capacity of the instance and the amount of resources consumed by each container, which is showing right at the top right of the page. And then this would make it easier for me to investigate any issues that occur from containers not running or errors in processing. And that's all I have for today. Let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.